Let's talk about evaluating logarithms without a calculator. So when we have something like log base 9 of 81, sometimes it's easier to think of these in terms of exponential functions. So oftentimes I think about, okay, if I'm trying to solve this or to evaluate this, I want to know what does it equal? So you can say it's set equal to a question mark, or you could even put a variable there. But in doing this, you now have an equation that you're solving. And because we know this equation, we can go back to how we would rewrite a logarithm in exponential form. So log base 9 of 81 equals x is the same thing as saying 9 to what power, or 9 to the x power, equals 81. So every time you're looking at these, you're asking, what does the base have to be raised to the power of in order to get this number? So 9 to what power is 81? 64 to what power is 16? In this case, it's the natural log, so e to what power is 1. So in this case, we know that 9 squared is 81. So if we're evaluating log base 9 of 81, we would get 2. I'm going to skip around on a couple of these because some of these are a little bit more challenging than others. So I'll come back to this one here. Let's go back to this one over here, the natural log of 1. Again, you could think of this as log base e of 1. So you're essentially asking yourself, e to what power is 1? Well, any number to the power of 0 is 1. So e to the power of 0 is 1, meaning the natural log of 1 is 0. The one below it, the natural log of e to the 8th. You could think of this, again, as log base e of e to the 8th power. If it helped to write it like the equation, then let's do that again. So if we said, what does this equal? We're going to set it equal to x, which means now I can rewrite it as an exponential equation. So the base e here to the x power over here should equal what we were taking the log of, e to the 8th power. So since e to the x equals e to the 8th, that means that x must equal 8. So our evaluation would get us 8. Over here, log base 5 of 5 to the 8th power is going to be very similar. Again, if we said this equaled y, for instance, then rewriting this in exponential form, we would say 5 to the y power equals 5 to the 8th power. Therefore, y would equal 8. So if we were to evaluate it, we would get 8. So now let's go back over here to this one, log base 64 of 16. We are essentially asking 64 to what power is 16? So in solving this, we can first of all tell when you're raising 64 to a power and you're supposed to get 16, I know that my answer is going to be less than 1. Because if I raise 64 to the first power, I get 64. 64 squared, I get something much bigger than 16. So I know that I'm going to have a smaller answer here, something smaller than 1. When you can't figure this out just by looking at it, like in this case, I knew 9 squared was 81. That's something we know off the top of our head. What you want to do then is rewrite both sides of the equation as powers with the same base. Powers of the same base. I'm going to show you why. So 64 and 16, these are both powers of 4. 64 is 4 cubed, and 16 is 4 squared. So what if I rewrote 64 as 4 cubed? And what if I rewrote 16 as 4 squared? Well, don't forget, 64 is being raised to the x power. So it's 4 cubed raised to the x power equals 4 squared. Well, remember, if you raise a power to a power, x squared to the 5th power, you multiply your exponents and you would get x to the 10th. So 4 cubed to the x power would be 4 to the 3x power, and that's going to equal 4 squared. So since the left side equals the right side and they're both powers of 4, then that means that the 3x here, this exponent, should equal this exponent. So 3x would equal 2. And solving for x, we would get x equals 2/3. That means log base 64 of 16 is 2/3. Let's try another one. Log base 5 of the 4th root of 25. Again, we don't know what this equals, So sometimes rewriting it like an equation can help us to rewrite it as an exponential equation. So the exponential version would be 5 to the x power equals the fourth root of 25. Again, this isn't as clear to me as maybe this one was. So like we did here, I want to rewrite these as powers of the same base. So we have 5 to the x power over here. Let's think of, is there a way to rewrite this side as a power of 5? Well, first of all, maybe think of rewriting the fourth root of 25 as 25 to the 1/4 power. Maybe that's going to be helpful first. But then we do know that 25 is 5 squared. So we know that this is going to be 5 squared to the 1/4 power. Again, a power raised to a power. We multiply our exponents. So 5 to the x power is equal to 5 to the, well, 2 times 1/4 is 2/4, or 1/2. So that means our x equals a half. So if we were to evaluate log base 5 of the fourth root of 25, it's going to be a half. Let's just try a few more. Log base 9 of 27. We don't know what it equals, so if I write equals x or an unknown, I can rewrite it in exponential. So 9 to the x equals 27. I don't know 9 to what power is 27, so I'm going to rewrite both of these as powers with the same base. 9 and 27 are both powers of 3, so I could rewrite 9 as 3 squared, and that's being raised to the x power, equals, and then 27 is 3 cubed. 3 squared to the x power is the same thing as 3 to the 2x power, and that will equal 3 cubed. So therefore 2x should equal 3, and therefore x equals 3/2, or 1.5. So if we were to evaluate this log, it would be 3/2. Sometimes we take a logarithm of a fraction. So if we want to take the log base 4 of 1/8, we're asking ourselves 4 to what power is 1/8? Again, I might not know it off the top of my head, so how could we rewrite both of these sides as powers with the same base? Well, 4 and 8 are both powers of 2, so I could say 4 is 2 squared, and then over here we would have 1 over 2 cubed. But we don't really want that fraction, so we want it to be just be 2 to some power over here, which I know that I could actually rewrite that. We have 2 to the 2x. This is going to equal, if I wanted to move this to the numerator, I could change it to be 2 to the negative third power. Therefore, 2x would equal -3, so x is -3/2. So when we would evaluate that, we would get -3/2. Last one, the natural log of 1 over e. So again, this is a log base e of 1 over e. So we're asking e to what power is 1 over e? So e to what power is, well, if I wanted to rewrite this as e to a power, that's going to be e to the negative first power. Therefore, x is -1. So if we were to evaluate this, we would get -1.